Find dy dx when e to the y equals x squared over y. All right, so this is implicit differentiation. I'm going to d dx e to the y, d dx x squared over y. Now the left side is not crazy at all. You take the derivative of e to the y with respect to x is still e to the y, but you attach dy dx to it. Okay? On the right side, you have quotient rule. Ugh. Quotient rule says that if you have a u over a v, you're going to have u prime v minus v prime u all over v squared. So u in this case is x squared. V is y. U prime is the derivative of x squared with respect to x, which is 2x, no attachments. The derivative of v is going to be v prime, and the derivative of v prime is the derivative of y, which is 1 with respect to x, so you attach dy dx. So really that 1 is not necessary, it's just dy dx. V squared is going to be y squared. Like that. So the right side is going to end up being u prime v, so 2x times v, so y, minus v prime, so dy dx, u, x squared, all over y squared. So let's do this. Let's multiply both sides by y squared. So we get y squared e to the y dy dx. Let's clean up the numerator a little bit. So we get 2xy minus x squared dy dx. I have to get both of my dy dx's on the same side. So I have to add x squared dy dx to both sides, add x squared dy dx to both sides, that crosses out, and gives me y squared e to the y dy dx plus x squared dy dx equals 2xy. Let's factor out the dy dx from both of those terms. When I do that, I get dy dx times the quantity y squared e to the y plus x squared, and that still equals 2xy. Let's divide everything by y squared e to the y plus x squared. And I'm left with dy dx equals 2xy over y squared e to the y plus x squared. And that's all I have to do here. I mean, not that it's all I have to do. It's not an easy problem, not by any stretch of the imagination, but it's not like I have to plug in numbers or anything like that. We just get a really gross looking answer. And that's what you get. Fun.